Welcome to the viewers. Now we discuss problem of rabbits for Fibonacci sequence. That we consider here a Fibonacci sequence actually applications. Now let us consider at first a second order homogeneous difference equations. Yn plus 1 equals to yn plus yn minus 1, taking it equation number 1. Which makes Fibonacci works and the sequence yn is said to be Fibonacci sequence. Now let us consider we put yn equals to c dash lambda n. In 1 we have yn plus 1, that is c dash lambda to the power n plus 1, and yn minus 1, that is c dash lambda n minus 1. Now putting this in this equation 1, better to say put this, then yn plus 1 and yn minus 1 equals to this. Now putting all of these, we have here we put c dash lambda to the power n plus 1, c dash lambda to the power n plus c dash lambda to the power n minus 1. Which imply if c dash is cancelled from everywhere, c dash is non-zero. Here c dash is non-zero terms, and it's clear that this is a non-zero terms, c dash. So cancel everywhere. Lambda to the power n plus 1 is equal to lambda to the power n plus lambda to the power n minus 1. That implies lambda to the power n also cancelled, and we finally got lambda square is equal to lambda plus 1. All of this cancelled because that means here imply lambda equals to 1 plus lambda to the power minus 1, which imply lambda square equals to lambda plus 1. If we solve these equations by Sridharacharya Pranali, then lambda equals to this type. Actually this is a characteristics equations. So we have here, since this is a characteristics equation, we have eigenvalues are, if we got a lambda 1 is equal to, we find by Siddharacharya Pranali minus b plus minus root over b square minus 4ac by twice a in this way. For quadratic equation we got minus b, that means 1 plus minus, we take one value positive and negative, that is 1 by root over of 4ac, 4 into we need to see, that is root over of minus 5 by 2, and lambda 2 equals to 1 plus root 5 by 2 is general solution of equation, that means here final equation 1. Equation 1 is then given by, since we know how to write this type of equations, and this is a basic property of linear algebra, so linear combinations of writing this kind of equations when you are solving this type of difference equations. And so the solution is given by yn, that is, if we consider here a lambda 1 to the power n plus a dash lambda 2 to the power n, that will be given by a into 1 minus root 5 by 2 to the power n plus a dash into 1 plus root 5 by 2 to the power n. We start here, if we write initial condition, that is y0 equals to 0 and y1 equals to 1, then put y0 0, that means term is 0, that is 0 equals to a lambda 1 to the power 0 plus, that means a dash lambda 2 to the power 0, that is a plus a dash, and also for 1 equals to 1 minus root 5 by 2 into a plus a dash into 1 minus root 5 by 2, 1 plus root 5 by 2. Just put for next case is 1, for n equals to 1, we get this result. Now we are getting the solutions. To finally the solution actually that gives the satisfied the equations. If we put here from the first earlier shows from a1 plus a2 a plus a dash equals to 0, and which indicates or imply a equals to minus of a dash, and 1 equals to a1 into 1 minus root 5 by 2 plus a into 1 minus root 5 by 2 plus a dash into 1 plus root 5 by 2, and then substituting a equals to minus of a dash. So a into 1 minus root 5 by 2 minus a into 1 plus root 5 by 2, that will be given by 1, and as simple as that, minus a by 2 is cancelled, then minus root 5 by 2a and minus root 5 by 2a, that will be given by 1. So here 2 into this, so minus root 5a is equals to 1. So we finally find a equals to minus 1 by root 5, and clearly a dash equals to minus of a, so it will be 1 by root 5. This gives then the general solution will be yn equals to, putting this value, minus 1 by root 5 into 1 minus root 5 by 2 whole to the power n, that is value of a into lambda 1 to the power n plus a dash into lambda 2 to the power n, and 1 by root 5 into 1 plus root 5 by 2 whole to the power n. This is the general solution of these equations. And here we observe, if we consider this condition of lambda 2, it is a lambda 2 that should be noted here. For lambda 2, it's clear, root 5 plus 1 by 2 is greater than 1, and for lambda 1 it is a negative cases, so minus 1 less than lambda 1 less than 0. Then the dominant eigenvalue, that means which is greater, that is called dominant. Is lambda 2 equals to 1 plus root 5 by 2, and its magnitude that guarantee that Fibonacci sequence numbers yn form an increasing sequence, that which show Fibonacci numbers yn form an increasing sequence. And we already know why these things happen. And since the eigenvalue lambda 1 is negative, its magnitude is less than 1, so fx is superimposed by slight oscillation that dies out if n increases. That means it is neglected for the second case, and lambda 2 is neglected for second case. So here is a corrections. It is not lambda 2, that's lambda 1 is neglected. So we write by diagonal elements, that is yn, that equivalent to 1 by root 5 into, this is a dominant element, so 1 by root 5 into, that is a lambda 2 whole to the power n. If we consider here, only we consider this element, so 1 by root 5, 1 plus lambda root 5 by 2 whole to the power n, that is 1 by root 5 into lambda 2 whole to the power n, and therefore we can write the Fibonacci number, the ratio, successive ratio Fibonacci numbers, that is yn plus 1 by yn, converges to yn plus 1 by yn equals to lambda 2, that is 1 plus root 5 by 2, and this is known as golden mean. Now we end our discussion. If you like this video, like it, share it, subscribe the channel. Thanks for watching.